We all know that the world rotates. In fact, the speed of the Earth around its axis is approximately 1,670 kilometers per hour at the equator. But have you ever thought about why we can't feel this rotation while the world is turning? The reason why the speed of the Earth is not felt is because it rotates with the atmosphere. World rotates on its axis from west to east. It completes this rotation in 24 hours. This period of time for one rotation is called 1 day. This speed decreases towards the poles and becomes 0 kilometers at the poles. As we know, the world it revolves around the sun and itself within the framework of a certain rule. The days with these rotational movements, seasons and years. In this video, we will examine the movements of the world and the results of these movements together with you. By the way, if you like the video, don't forget to like and subscribe. If we go deeper on this subject, that is, if you ask how many kinds of movements the Earth has, there are 2 different movements of the Earth. The first of these movements is rotating around its axis. The second is the rotation of the sun is defined as. Thus, we can easily answer yes to the question of whether the Earth moves. Now that we have answered this question, I think we can switch to the day and night cycle. Day and night occur as a result of the daily movement of the Earth around its axis, which is thought to pass through the poles. The sun's rays during the movement of the Earth, while the round one illuminates one side of the world, the other side remains in darkness. Logically, the illuminated part is during the day, the dark part is night. World, since it rotates from west to east, the eastern point sees the sun earlier than the western one. And remember that night and day only become equal all over the world on March 21st and September 23rd, and each is 12 hours. The sun is visible at both poles on this date. On Earth, the length of day and night are equal. This is the date of the 6-month night at the South Pole. At the North Pole, it is the beginning of the 6-month daylight, because on these dates, the sun's rays are perpendicular to the equator. If we look at the movements of the sun during the day, the first sight of the sun is called sunrise. This time, it is morning. When the sun reaches its highest point, it is noon. In the evening, the sun's rays become flat again. The sun becomes invisible for that point, which is called sunset. Sunrise and sunset is the movement of the sun. If we go back to the movement of the Earth, which is our main subject, there are some experiments done. Whether the Earth rotated around itself centuries ago, it was also one of the most heated debates among scientists as to whether the Earth orbits the sun or the sun orbits the Earth. Even Galileo Galilei's "The World is Turning," it is known that she was prosecuted for what she said. 10 of Muslim scientists, there are written sources that claim that the Earth has rotated since the 19th century. Until the 19th century, some scientists explained the movement of the sun and stars in the sky with the rotation of the Earth. So the evidence for the Earth's rotation was based on observational data. However, the French physicist Léon Foucault, she prepared an experimental setup to prove the Earth's motion around its axis and exhibited it at the Paris Observatory in February 1851. Thanks to a lead ball attached to the end of a steel rope suspended from high, it was experimentally proven for the first time, independently of sky observations, that the Earth rotates around its axis. In fact, another issue that is as important as the question of the motion of the Earth is the shape of the Earth. The shape of the Earth has been debated for centuries. For many years, the world has been depicted as a flat tray. However, this information is wrong. Currently, the world is thought to be spherical among the people, but in fact, this information is not quite correct. The shape of the Earth is elliptical and the Earth is bulged from the equator. It has a flattened structure at the poles. This special shape is called a geoid. By the way, our solar system is not the only thing moving. All other planets in the universe are also in motion, and the position of a celestial body. If you know the speed of movement and the direction of movement, you can calculate what positions it will be in the future by using the forces acting on that object. Scientists can make very precise calculations about the movements of celestial bodies. For example, today it is possible to calculate with great precision which comet will pass close to the Earth at what time, or when there will be a solar eclipse. It is also possible to make retrospective calculations as well as forward-looking calculations. However, researchers who recently calculated solar eclipses in the past found that the results did not agree with the records. For example, there are records of a solar eclipse in Babylon in 720 BC. By calculations, however, this eclipse should have been observed somewhere in the western Atlantic Ocean, not in Babylon. The difference between the calculations and the records is due to the slowing down of the Earth's Earth's rotation speed around its axis in the intervening time. In the last 2,740 years, the length of a day has grown by an average of 1.78 milliseconds per century. There are various factors that cause the rotation speed of the Earth around itself to change over time. Friction between seas and land. It is one of the factors that slows down the rotation speed. According to calculations, if this friction were the only factor affecting the rotation speed of the Earth, the length of a day would increase by an average of 2.3 milliseconds every century. One of the most important factors that cause the rotation speed of the Earth to change is the changes in the Earth's crust. When ice skaters open and close their arms as they spin, their spin speed changes. A similar situation applies to Earth. During the last ice age, the regions near the poles were covered with thick layers of ice. As the world warmed, with the melting of the ice, the heavy ice load in the polar regions decreased and the Earth's crust began to stretch outward in these regions. At lower latitudes, the Earth's crust collapses inward. These relatively recent changes are causing the Earth's rotational speed to increase around its axis. There are also minor changes in Earth's rotational speed on 10-year timescales. According to the researchers, the reason for these changes in short time intervals is the interactions between the Earth's solid inner core and liquid outer core. However, for now, these interactions between the inner and outer core are not fully understood. I think we've questioned enough about this topic in today's video. As Saktaras said, the unexamined life is not worth living.